All right, we're going to start section 3.4, finding and using slopes of lines. It's going to be a little bit of review of algebra, so hopefully that makes some of you happy. And if you remembered slopes of lines before, we'll review it for a little bit. Okay, the slope. The slope of a non-vertical, so non-up and down line is the ratio of the vertical change, the rise, to the horizontal change, the run. So, little graph here. Okay, if I have a point and a point, I'm going to have the rise and the run. So with the run, I have x2, y2. And with the rise, with this one, let's say I have x. Let's make that the same color. x1, y1. Okay, so when we say change, that means subtraction. So I take y2 minus y1, which is right here, and x2 minus x1, which is right here, and subtract them. So when I say it's the ratio, that means that it's a fraction of the vertical change, which is the rise, to the horizontal change, which is the run. All right, some key concepts about slopes of lines in the coordinate plane. In green, I have a picture of a negative slope. It falls from left to right, as in line J. When you think, if you read, I read from left to right, so we always go from left to right. So negative slope, I'm skiing down, left to right. Positive slope, I'm hiking up, okay? Left to right, I'm hiking up a hill. Zero slope, I don't know. It's always hard for students to remember zero slope, but if you look at the word zero, it has horizontal lines in the Z, okay? Zero slope, horizontal lines are in the Z. It has a slope of 0. Undefined slope, it's a vertical, as in line N. So if you look at the word undefined, U has 2 vertical lines in it when you make the U. So undefined is a vertical line, so I have 2 vertical lines in the word U. So undefined is a vertical line, as in line N. All right, let's find the slope of line A and D. Okay, line A is the blue one right here. And basically we just need to pick the 2 points. I have rise over run, or change in y over change in x. So let's find our points. Sorry about that. So for A, my points are 6, 4, and 8, 2. It does not matter which is your first point and which is your second point. You just need to be consistent when you're subtracting them. So I'm going to do y2 minus y1. 2 minus 4. Excuse me. And then x2 minus x1. 8 minus 6. 2 minus 4 is negative 2. 8 minus 6 is 2. Your slope is negative 1. Okay, some of you, and it's no big deal, may still get confused adding and subtracting positives and negatives. If you want to double check with your calculator, I will not complain. At this point in your math career, I want you to get the right answer. Okay, I'm not going to reteach how to add and subtract negative numbers because you guys should know that by now. So let's do B, line B. Oh, line D. Let me erase that. I need line D. Line D is red. My points are, again, 6, 4, and 6, 0. So change in y, 0 minus 4. Over change in x, 6 minus 6. That gives me 0 minus 4 is negative 4 over 0. I cannot divide by a 0, so it is undefined. And if you remember that definition from the previous slide, you don't even need to do the subtraction because you learned that vertical lines are undefined. Okay? Okay, you try this one. Push pause and try it on your own. You're looking at line B. There you go. I chose the 2 points, did change in y over change in x, and got a slope of 2. Okay, try on your own, line C. Okay, line C, I picked 2 points on line C and did change in y over change in x, got 0 over negative 6, and we learned that horizontal lines have a 0 slope. Okay, horizontal lines have a 0 slope. Alright, let's learn another postulate. In a coordinate plane, this is postulate 17, slopes of parallel lines. In a coordinate plane, 2 non-vertical lines are parallel if and only if they have the same slope. And then we can also say any 2 vertical lines will always be parallel. If you know 2 lines are vertical, they're both vertical, that means they are both parallel, which is sort of fun. In the word parallel, I have 2 vertical lines which are parallel. So slope of 1, m is your shortcut for slope. It's your abbreviation for slope. So m1 equals m2, and I'll draw you a picture in a sec. So there I have my 2 lines. I've drawn the red arrows, which signifies that they are parallel. This line has a slope 1. M is short for slope, remember. This one has a slope 2, and we know that slope 1 equals slope 2. Postulate 18, there would be another typo. Let me fix that for you. This is postulate 18, slopes of perpendicular lines. In a coordinate plane, 2 non-vertical lines are perpendicular if and only if the product of their slopes is negative 1. So I have 2 lines, which will be written as perpendicular. Okay, I have m1 and m2. If I multiplied the slope of the first line times the slope of the second line, my product, my answer, would be negative 1. Horizontal lines are perpendicular to vertical lines. So if you have a horizontal line and a vertical line, they are always perpendicular. Alright, find the slope of each line. Which lines are parallel? Okay, K1, change in y, so I have 0 minus 4. Remember, you always go in the same order. So if I did 0 minus 4, for change in x, I have to do negative 3 minus a negative 2. Zero minus 4 is negative 4. Negative 3 minus negative 2 is negative 1. So my slope is 4. Let's try the next line. Change in y. This time I'm going to go from the top to the bottom and show you that it doesn't matter. Okay, 5 minus 1 and 4 minus 3. 5 minus 1 is 4. 4 minus 3 is 1. My slope is 4. See, it didn't matter. Okay, K3. Negative 2 minus 3. Change in y. And change in x. 5 minus 6. Negative 2 plus a negative 3. 5 minus 6. Hold on. 5 minus 6 is negative 1. Goodness. There we go. I knew that was a positive slope because how from left to right it goes up. So when I got a negative answer, I knew that couldn't be right. So these two have the same slope, therefore they are parallel. There's 2 R's. Sorry about that. Those are parallel. Very interesting way to write parallel. And K3 is nada, nothing. Okay, it's not parallel, it's not perpendicular. Okay, you try. line M passes through those 2 points, line T passes through those 2 points. Are the 2 lines parallel? Explain how you know. Push pause, please. Okay, I calculated the slope of line M, got -2/5, and the slope of line T got -2/5. Notice it does not matter if the negative came out with a 5 or if the negative came out with a 2. This is a negative number, that's a negative number. So yes, they are parallel because the slopes are equal. Okay, last example for this first part of the video. Line H passes through those 2 points. Graph the line perpendicular to H that passes through the point 2, 5. So we need to know the slope of line H, because the perpendicular slope is actually, which wasn't said earlier, is the opposite reciprocal, and I'll go over that in a second. So line H, line H, let me erase that. The slope of H is 6 minus 0 over 7 minus 3. I get 6 over 4, simplifies to 3/2. Okay, the perpendicular slope remember, the slopes of 2 lines that are perpendicular has a product of -1. So that means I need to do the reciprocal and the opposite sign. Okay? Because 3/2 times -2/3 equals -1. So your perpendicular slope is -2/3. Okay, when it says just to graph the line perpendicular to that, point 2, 5, oh, the answer's already here. What I would do is just go up to 2, 5, put a dot, and use the slope. Okay, I have -2, +3. Put another dot, and then draw a line. Okay, you could also say, so we did -2 over 3. You could do 2 over -3 by going +2, 1, 2, and -3, 1, 2, 3, and it's right there. So it doesn't matter where the negative ends up, you're still going to get the same line. Oops. Alright, we're going to do that one later. We're done for today.